I am Winston, and I'm a huge fan of the Divox UK. As a politician, I fear the rise of AI and its potential detrimental effect to democracy. I'm therefore very happy to present to you today my dear friends Jonas, Thomas, and Martin with their fabulous talk about the AI election, how technology could shape public sentiment. Please welcome them to the stage.
Hello London and hello Divox. It's really nice to be here, and we welcome you to the AI elections, how technology could shape public sentiment. So, yeah, Mark already introduced ourselves, but maybe you want to add something, Thomas?
Yeah, so one thing that we are very proud of is the so-called innovation hacking team. So I'm Thomas, and I, together with Martin, 10 years ago we founded it. And back in the days we were talking about things like gesture control, VR, AR, but then we moved on to AI, and we've been doing that for a long time now.
Yeah, right. Yeah, innovation hacking. So my name is Martin FÖRTSCH, computer scientist, and yeah, we want to talk about AI today, real-time deepfakes. You will really enjoy it, hopefully. And Jonas?
Yeah, my name is Jonas. I'm the youngest member, and I am the one who builds all these fun things that we want to talk about today. But yeah, what exactly are we talking about? You said deepfakes, something like that. How
Yeah, right. So it's this one.
Guten Abend zusammen. Willkommen bei Lesh Kosmos. Unser Thema heute Deepfakes, eine Technologie, mit der man praktisch jeden alles sagen lassen kann, und zwar in Echtzeit.
Das klappt ja wunderbar. Mit dieser Technik kann ja jeder eine Wissenschaftssendung moderieren, sogar du.
Ich und eine Wissenschaftssendung? Was für eine absurde Idee. Aber wenn meine Stimme da nicht wäre, dann könnte man mich wirklich für dich halten. Und überleg mal, wenn man das woanders einsetzt, dann kann man damit ja eine völlig neue Dimension von Fake News schaffen.
Und das macht mir echt Sorgen. Die Möglichkeiten zu manipulieren sind damit ja schier unendlich.
Ja, man könnte zum Beispiel irgendeiner Politikerin oder einem Politiker irgendwas in den Mund legen. Also was ganz Fieses. Und eine andere Regierung nimmt das dann ernst und drückt vielleicht auf den roten Knopf.
Wie so oft waren andere schneller als du und haben genau das gemacht.
Yeah, somebody else did this. So this was a TV show that we did together with German television back in the days, back in 2021 actually. And shortly after the war, really, there was a deepfaker who made a video where he depicted the Ukrainian president Volodymyr Zelensky, who asked the Ukrainian forces to lay down their arms and surrender to the Russian army.
Yeah, and this was actually not part of the original broadcast, in case you were wondering. We put that in there after the fact, just to show you why this is important to talk about today, right?
Yeah, exactly. And when it comes to technology like this, we keep it like Carl Bergström from the University of Washington, who once said, when a new technology like this comes along, the most dangerous time is when it's out there, but the public is not aware of it, because then we can use it or not we, but the bad guys can use it effectively. And that's why we want to talk about this today. So, Martin, what are the potential dangers?
Yeah, so the motivation behind this talk is that everywhere warnings are issued about the danger of AI and producing fake news and stuff like that. And so we made some research and to discuss this here, and we found something which already happened. So of course it was the Cambridge Analytica scandal. So 87 million of personal profiles which just harvested without the consent of the people, and they created psychographic profiles to find those people who are easily convincible to vote for a specific person. And why is this of interest? Especially in 2024, we have the situation that half of the world's population has elections. Let's have a look. The US, the European Union, India, and of course here in the UK in the, I think, beginning of 2025. So AI, votes, and so on. Why is this of interest regarding AI? Let's have a look to the study of the MIT from, I think it was 2018, and there is this message, this core message: false stories, they spread 6 times faster to reach 1,500 users than compared to true stories. And this is really interesting, and the question you might ask yourself: are we doomed in a world dominated by fake news? And this is what we want to discuss today, and where we want to shed some light on it. So, first question: what do these images have in common? For example, this one. This one. Here we have Boris Johnson. And you might won't believe that, but this is Boris Johnson as well. So I'm not sure why he's doing this. But let's have a look. So all these pictures are real, except one, to be honest. It was the picture with Angela Merkel and Obama. Who recognized that? Okay, a few. Okay, that's good. So how was this created? Yeah, with text-to-image AI. In this case, we used Midjourney, and the prompt on this example here was an oil painting of Angela Merkel. Yeah, looks good, really nice. Let's have a look to another example. Some of you might know this. We made it on our own very easily. Pope Francis wearing an extremely puffy white down jacket in the style of Balenciaga street photography. No advertisement here in this case. Yeah, one. Last but not least, Barack Obama winning a dance battle against the super devil in a moody black hip-hop club mosh pit with cinematic lighting 1920 colorized. Yeah, so you can see, with text-to-image, it's easily possible to create situations of politicians that have never been at least not in the public.
Yeah. And actually, not just text-to-image, but AI in general.
Right.
And what we want to do today is have a look at a couple of examples of how we can create fake stuff with AI and see how we can protect ourselves against it.
Yeah, right. So let's have a look to the AI timeline. It was in 1966 when ELIZA was programmed by Joseph Weizenbaum, one of the first chatbots. And it took 50 years that deep learning was written in a paper by the University of Toronto. And after that, there was an explosion of AI apps. You all know we have them in our daily life. So now we want to answer the question, how does a neural network work? Because we need this understanding for the real-time deepfakes, for our chatbot, which produces shit postings, and so on and so on.
Yep. So let's have a very, very brief look at AI. And to go back to the foundation of AI, we have to go back to school, and there's the human neuron. The human neuron basically exchanges electrical signals with other neurons via dendrites, and to do that, it collects stimuli from the surrounding neurons, and if the stimuli are high enough, then there's a so-called action potential, and the neuron fires. So it fires their information, and this gets propagated to the next neurons again. And if the stimuli are not high enough, then we will have a failed initiation and nothing else will happen. So basically, it's like a cutoff function, so 0 or 1, right? So there was a brilliant mathematician who really modeled this into a so-called artificial neuron, and there we also have an input, which is in our case x0, then we have some weight for the connection between these different neurons, and then we also have a bias within each neuron, because this is how reactive the neuron is in the end. And then we will put all of that, just add up all the different stimuli at the bias, and then we can put that through an activation function, which could be something like a cutoff function, and this will then be propagated to the next neurons. And we also made a beautiful animation for that, and as you can see, the lower the value for the weight is, the less important it is for the final value. And then we add the bias, and then we put it through the activation function, which in this case is not a cutoff function, but rather a rectified linear unit, so basically just a linear function. So now that we have that out of the way, we should also think about how is an image represented within such a neural network. And there we can just have a look at this image, and you probably recognize that this should somehow be a face. And then we can put some numbers onto that, because we can just take the grayscale values, and a white pixel might be a 1.0, a black pixel might be a 0.0, and everything in between will be, of course, everything in between. And then we can just put that on each and every pixel within our image. And in the easiest case, we could then now just take the values that we get here, just have them one by one. So the first line will be the first 20 values in our input vector. The second 20 pixels, or the second row, will be the second 20 input values into our vector, and so on and so on. And we will have a complete vector with all the information from our image in the final thing. And then we can put them into our neural network. Neural networks are normally layered networks, so you have layer 1, and in a fully connected network, which we see here, every neuron from layer 1 is connected to every input value, every neuron from layer 2 is connected to every neuron from layer 1, and so on and so on. And then we will propagate the information through our neural network, and in the end we will get out an output value, which in our case is something like the probability that the image that you see is a face. So in our case it's 89%, which is pretty good. And now let's put something else in, for example a duck or something like that, and we propagate the information through again, and we get something which is 23%, so we could say this is not a face.
Yeah.
But
what is our typical reaction in this case?
That's
Yeah,
good. That's good.
That's good. But if we have something like that, then our reaction would be rather something like that. But
Yeah.
what can we do then?
Yeah, it's kind of, the network isn't behaving as we want it to, so what we have to do now is we have to punish it. And in order to punish it, we punish it the same way as we would punish humans, and that is with money. So in practice, this money is a so-called cost function. That's basically a metric that tells us how good or how bad is our neural network currently. So you can do the following. For example, here we have that image of our face. We can put that into our neural network, and it will come up with an output value. That output value is 0.82. That is an 82% probability of it seeing a face. And what we can do now is, because we know that our input is for sure a face, so that corresponds to a value of 1, we can compute a so-called cost function. So that cost function is, in our case, mean squared error. That means we take the ground truth value of 1, we subtract 0.82, and then we square all of that, and then out we get a value of 0.03, which is actually quite low, because it's doing the right thing. And if we now put in the duck again, then the duck goes in, out comes 0.82. This time around, our ground truth value is 0, because the duck is not a face. And therefore, our cost function value now looks a lot different. So now it's a lot higher. And now we can see we kind of assigned good samples a low cost function, bad samples a high cost function. So we now have to minimize the cost over a data set. And that is what is called training in neural networks. And it looks a little something like this. So we have a data set that consists of inputs and ground truth outputs. And we feed those inputs through our model, and we see what we get out, compute a loss function or cost function with this, and we use that cost function to kind of optimize the model in order to get better and better and better. And how do we optimize that model now, right? How do you optimize a neural network? You remember in the neuron we have the weights and we have the biases as well. And those are basically the variables that kind of determine how our neural network behaves, what it does. So you can think of them as small little control knobs that we can now twist and turn in each direction and see if we will get better or if we're getting worse. The only issue here is for modern neural networks that we have, for example, as we're seeing in GPT these days, we have millions, if not billions, of these variables. So we would have a pretty large control board, and it kind of gets cumbersome to do all of this by hand, which is why some smart people came up with some very cool algorithms like backpropagation and gradient descent, and you can use those mathematical algorithms to train your model. And we, of course, did that. We trained a model. Well, somebody else did, actually. And we have a live demo for this.
Yeah. And fingers crossed that the computer will not crash.
You're jinxing it now. Oh, come on. There we go. Drum roll, please. Oh, looking good, actually. Looking good. There we go. So here you can see we have a neural network that we didn't only train on giving us a probability of a face, but of a bunch of different classes. So what we're doing here is a classification. And what, Martin, can you just stand in front of the camera for me real quick? And so what we can see right here is what it's detecting is we have like 50% chance of a lab code. Now we have still a lab code and a harmonica. We also have a stage. That is kind of legit. You can see, obviously, all right, what is this now? A binder. OK, sure, sure. You can see the model it's actually quite old. It's the VGG19 model. It was trained on a bunch of different classes, and none of them are on the stage right now. But now you know, now you've understood how neural networks work under the hood, and now let's have a look at how those can be used to create fake media, starting with real-time deepfakes, right?
Yeah, absolutely. So let's have a look at real-time deepfakes. So a real-time deepfake is basically what you saw in the video at the beginning. So you have the face of a person, you take that person's face and you transcribe that to another person's face, but the remaining part will be the facial expressions of the original person. So it looks like it is a completely different person. In this example here, you can see Harald Lesch on the left, and you can also see him on the right. So basically, only one of them is the real Harald Lesch, namely the one on the left. And we will now have a look at how these deepfakes are created, or how we created real-time deepfakes. There are a couple of steps involved in the creation process. The first one being the most boring one, of course, we have to grab the camera image of course. But then the next one is going to be a bit more interesting, because we really have to find out the different points in the face. And we have to do a face detection to find out where the face is located. And therefore, we are using a library called MediaPipe. And within MediaPipe, there is an algorithm called face mesh, which basically matches 468 landmark points within your face to this mask that you see in this example.
You won't believe it, but we have a demo on that.
Oh, really?
Yeah.
OK, then let's try that out. So here you can see Martin's face. And we have 468 landmark points in Martin's face, and
Lovely.
You can see that it works perfectly, and it matches the mouth to the mouth, and so on, and so on, and so on. And it works in real time, which is good, because we need it in real time, right? And it also works with if Martin puts his hand in front of his face, or if he looks at it sideways into the camera. So that's
nightmare material.
pretty good.
Thank you for that.
So now that we know where the face is, the next step that we need to do is we need to do a so-called face segmentation. So basically, we need every pixel of the face, or not even the face, but rather the head, because we really want to replace the complete head. And for that, we will just train a neural network, and this neural network will then just color paint everything in blue, which belongs to the head.
Guess what?
Huh?
We have a demo on that.
Oh, perfect, yeah. So let's have a look at the demo again. And here you can see Martin's face is a little bit bluer than it used to be.
Spent a bit too much time at DevRocks yesterday.
Yes, right.
Yeah.
Definitely.
Suffocating a little bit. But as you can see now, if Martin's turning his head to the side, please do it a little bit more. OK, you can see that the illusion breaks at some point, and the distinction between head and neck is also not perfect. This is because we trained it in our own style, so we trained a neural network to recognize or to segment the image, actually. And we used a training data set for celebrities for that, and unfortunately, celebrities don't like looking sideways into the camera. So we don't have that data available. OK. Now that we have that, the next demo is coming, I know that. We have to eradicate the old face, because basically we don't want the old face shining through if we put it on a new face. For that, we are using a simple technique, I would say. This technique is basically called inpainting. So inpainting is what happens when you have old photographs, you have some scratches on them, and you want them removed, and you use Photoshop for that. And with that, the pixels from the surrounding flow in. And you can see the same as well. So Martin looks way better now than we used to be. But as you can see, this is not a perfect solution, because nobody would expect that there was nothing there, right? And you can also see the finger pixels flowing in. But it's good enough for us, actually, because we only need to somehow the edges to be removed a little bit, because we want to put a new face on it anyways. So this worked for us as well.
Yeah.
But Martin, the next
At
slide
at this point in time, it's still boring, right?
Yeah. No, it's not boring. It's quite
Removing
interesting.
heads.
But now we want to replace the head. And yeah, this slide did not age that well, actually. Back in the days, in 2021, we really thought it would be a good idea to deepfake Putin onto Harald Lesch, because yeah, he has the same head shape and the same hairstyle, basically. So we thought, yeah, why not use him? Nowadays, of course, we would not use him, but rather the future Prime Minister of the UK. At least a competent person.
Mobile phones are falling down.
All right, but let's have a look at how a deepfake really works at its inner core. So at the core of the head replacement, we have a neural network called an autoencoder. An autoencoder basically takes a picture, and using some neural network, it reproduces the picture. But it does that in a very specific way. So we have an encoder which takes the image and puts it into a latent space representation. And the latent space representation basically is a compressed version of the face. So maybe something like, is the mouth open? Are the eyes open? Is the person smiling? So things like that might be found in this representation. And then we use a decoder network to reproduce the image. Of course, if we start with this process, it will, at the beginning, just reproduce some white noise, because it does not know what to do. And therefore, we have to train our neural network. So our loss function in this case, or our cost function, will be just the pixel-wise comparison of the output image and the input image. And with that, we can now train our neural network to reproduce the same image using a lot of electricity, actually. But this is still pretty boring. We get the same image out.
It's amazing. So you just put in Harald Lesch and you get the same Harald Lesch out.
Yeah.
Wow.
Pretty interesting. But it gets more interesting, actually, if we do a little trick, because we can now use two autoencoders, and we will basically take the encoder of Harald Lesch. Yeah, we will encode his face, but when we have that representation, remember, is the person smiling and so on and so on, so the whole facial expression is in this compressed version. And then we take the decoder, the wrong decoder, namely that of Dirk Steffens, the second one, and we will then have the facial expression of Harald Lesch, but with the face of Dirk Steffens. And this is how a deepfake works in its inner core.
Thomas.
Yeah.
You won't believe this. We have another live demo of this.
Oh my God.
Yeah, let's have a look. All right, who am I?
Yeah, here you can see Jonas now, so he looks not like Jonas anymore, right?
Oh, who am I?
Does somebody recognize this person?
Probably not.
Yeah.
This is Brian, the spokesperson for Fujitsu. We deepfaked him a while ago, and ever since his face is
With his
ours.
consent.
Well, yeah, sure. Ever since then, his face is ours, right?
Do we did it with consent?
Yeah. He said it's cool, probably. Here we have another colleague, and you can see, well, we can do a deepfake in real time. Isn't that great? What else do we have? We have this guy, and we have this person right here. So you can see it works pretty stable. It works in real time. You can see we haven't prepared this. We're actually expecting this machine to crash any second, so just to prove that it's a live demo for you, right? And it works for any kind of gender, for any kind of ethnicity. And this obviously is not something that, well, yeah, that's it for the faces. But this is obviously something that you could now do a lot of stupid stuff with, right?
Yes.
So let's talk about that.
Let's talk about it.
Beautiful.
It's just a few weeks ago, there happened something strange. So a Hong Kong company just lost $25 million because a person was within a video call together with 12 deep-faked persons. At least this is what the police was stating in the news, and yeah, tricked by deepfakes. This is crazy. And yeah, before this happened, we already did some experiments. And here again with the German television, so that we make it somehow legit. Pro7 Galileo is some popular science magazine, and here you can see Harro Füllgrabe, the man with the hair in front of the display, and inside the video conference you can see Matthias Fiedler, the bald man. Yeah. From now on I just say the man with hair and the bald man, okay?
Right.
Okay, so let's have a look to the setup. So the man with the hair is sitting in front of a DSLR camera. The DSLR camera goes into our computer with the real-time deepfake software, and this signal gets transferred to the video conference.
Yeah,
so this is the setup, yeah?
Exactly. Now we're in Zoom, and now
Isn't
we want
that
to try,
easy?
can we fool people with this? Can we call friends, and will they
Yeah.
actually realize?
So the man with hair appears now as a bald man and calls the best friend of the bald man. Yeah? Let's have a look.
Hallo, Richard! Du glaubst gar nicht, was hier alles los ist. Die Leitung stimmt nicht, dann geht das in die Hose und das geht in die Hose und das klappt nicht.
Die erste Hürde ist geschafft. Der Chatpartner schöpft keinen Verdacht. Dann gehen wir einen Schritt weiter. Harro alias Matthias schickt ihm eine Datei.
So the man with hair sends a file to the best friend of the bald man.
What could possibly go wrong?
What could possibly go wrong? And the question now is, have been those real-time deepfakes good enough to fool him? So what do you think? Will he open the file? Raise your hand.
That's a lot of hands.
It's a lot of hands, okay.
Let's
so
see.
let's uncover.
Sein Gegenüber öffnet das Dokument ohne zu zögern. Gefährlich. Im Fall eines echten Betrugs könnte es sich um einen Virus handeln. Richard tappt in die Falle.
Hast du es bekommen?
Jetzt habe ich es bekommen.
Yeah. You received the file, yeah, okay. We did a lot of experiments, so we also called the parents of the bald man, trying to fool them, and so on, but you can see within video conferences, real-time deepfakes are good enough because of downscaling, compressing, and stuff like that. Some problems of real-time deepfakes get somehow erased.
Yep.
Yeah.
So let's have a look at the different things that we did here. So we had controlled conditions in this example. So here you can see on the left, again, Harald Lesch. In the middle we have the face mask, and on the right, because we have not seen him enough today, again, Vladimir Putin. But let's have a closer look at that and how you could spot such a deepfake. And here you can see, yeah, the level of skin detail, it's not as detailed on the right picture as it is on the left, right? Then we also have unusual distortions whenever Putin is blinking. The artifacts around the head, you can see it on the hair maybe a little bit. And also, since we trained on not that much training data, there's also kind of a lack of emotion. But there's more. So you can also have something like everything unnatural. The coloring of the skin might also be a little bit off, maybe. And if you can see a person smiling, then the number of teeth must not necessarily be correct, and things like that. But these are all things that are valid with today's deepfake, but the next generation of deepfakes might not be that
That's
subtle
right.
anymore.
So one thing that we should probably add here, so we built some real-time deepfakes, but at the same time we realized, well, could be a dangerous tech if it came into the wrong hands. So we decided just to talk about it and do fun demos and not share the code with anyone. So in case you were asking yourselves, no, you can't have the code. With that out of the way, let's close off deepfakes and talk about something way more funny, which is social media bots, Martin.
Yeah, social media bots. So we just saw how we fake people, but what about, text, faking text. So in the study of Imperva, the amount of automatic generated content by bots, they say with their experiments and research, they assume that 47% of all content which is generated by bots.
Wow.
And approximately 32% of these bots are bad bots, and the rest are good bots. And this brings us to
Our own.
another project we did.
Yeah.
Jonas.
Yeah, exactly. I mean, from the number here, you can see obviously this is a factor that might influence elections.
Maybe
And so let's talk about
maybe a
social
few other numbers. 75% is in another study was told to be generated content, and they say they expect at end of this decade over 90% of content in the internet is automatically generated.
Yeah, so let's talk about social media bots, and who better to talk about this than us, because we have built one in the past. And we call it the shitposting AI. And the problem that we were trying to solve, you know, we built deepfakes, we built some other showcases in the past, and every single time we do, there's some kind of a media response, and the worst part about it is that there's people out there who feel the need to give their opinion about what we're doing. So for example, here we picked a comment from like a German tech website, and we translated it to English. So it starts off very good. The employees at TNG Consulting. That's not what the company that we work at is called. It's called TNG Technology Consulting, by the way. And yeah, what do? We cover the cam with tape on our notebooks. How do I know? Because everyone does that. I still think that maybe we have been unfair to the Amish people. So if you know what this has to do with deepfakes, please tell us, because we don't, and we're wasting a lot of time reading these kinds of comments, and even worse, we spend a lot of time replying to those comments, because we have to get our point out there as well. And over time, we realized, okay, we're spending more and more time arguing with people on the internet and less time doing the stuff that we care about, tech. So we took a step back and kind of modeled what is going on here, and we came up with what we call the shitposting cycle. So on the right, you can see the average troll writing a shitpost about one of our projects, and on the left, you can see the very average TNG consultant who then has to sit back and reply to the shitpost, but that's not where the conversation ends, right? Nobody ever changes their mind on the internet. So the shitposter replies back, and we reply back, and this goes on and on and on forever, and eats up a lot of time. And us being IT folk, we thought, well, what a great idea would be to just automate that way. So let's, for example, think of having a bot here in my stead, and so I can do some work now, and the shitposter can argue with the bot forever, but then at the same time, the shitposter is also kind of wasting his time. So let's just take the human completely out of the loop. Now we have this floating AI brain here that does natural language processing to write a shitpost and reply to itself in all of eternity. So now we can do some work, and even the shitposter can do something nice with their time. So that's the plan that we wanted to do, but if you paid close attention earlier, we want this to be an AI, a neural network brain that now has to process text, but neural networks process numbers, right?
Yeah.
So how does that go together, Thomas?
Yeah, so what we now have to do is we have to take the sentence that we have here and put it into numbers again. We could, of course, take every character, assign a number to that, and we would be fine. But unfortunately, this does not work that well, so why not take every word that we have in our sentence and assign a number to that? So this is exactly what tokenization is about. So we have computer science is so nice here. And we can then randomly, or in a pseudo-random way, just assign some numbers to that. We did this, so computer might be 42. And so, as you can see in this picture, is 2 times there, and it's always the token number 3. And since we don't we don't want to just randomly assign to each and every word that might be existing out there a number, we are just taking some well-known words, and for the others that are not so well-known, maybe German words like Donaudampfschifffahrt, Kapitänsmütze or something like that, we will just assign to different parts of the words some tokens. And we have our most boring demo today with us, which will basically just show you how tokenization works.
Okay, so I just typed in the sentence, welcome to the DevOps keynote.
Yep. Let's try it.
Output.
And wow.
Then, yeah.
And as you can see now, welcome has its own token ID, but DevOps does not, because it's not that commonly used in English language.
Unfortunately. So let's try something fun, because this tokenizer that we're using here, it's called the byte pair tokenizer, also used by like these small neural networks called GPT. So those are trained on English. And we can now do a fun thing. We can type in a German sentence and see how it struggles to kind of properly tokenize that. So if we now put in Willkommen zu der Devox-Konferenz. Sure, let's just leave out some words. All right, let's see. And now you can see, before we had welcome as one token. Now we have Willkommen, which is the equivalent of welcome, split up into multiple subtokens. So that's an actual problem that people have when dealing with tokenizers and different languages.
Okay, enough with the boring demos. So let's get to the point where we really put this into our neural network. So now we can just take the tokens. Of course, we left multiple steps out on the way, but we can just fill our input vector with whichever tokens got out there. And since we have a fixed length of our input vector, also known as the context length, we can just pad the rest, just put in some information about, so that the neural network knows that there's nothing in there as well. And this will then go into our neural network. And then we just propagate it through. And in the end, we could have something interesting, like we could just predict the probable next token that might come out. Right, Jonas?
We could, in fact, do that, but we should probably not be using this neural network here exactly. All right, so let's have a look at what neural network we use for our shitposting AI, and we used a very niche neural network from like a very small AI startup. You might have heard of them. They're called OpenAI, and the neural network is called GPT. It looks a little something like this, and we want to have a look at what GPT actually means. So GPT, that stands for Generative Pre-trained Transformer. And that name is exactly the reason why we are using it here. So generative, that means we are generating text. So we're not doing a classification as before, but we're generating new content, which is what we need for shitposting. Pre-trained means, well, it comes pre-trained on basically the entire internet. So it has learned how, well, language works, how the English language works mostly. And so what we only have to do is to provide a couple of samples during training to make it shitpost. And then finally, we have transformer. Do I even have to say anything? Unfortunately, that's not what transformers look like in AI. Transformers are a very special kind of architecture that has become very powerful at doing these GPT things. And we want to have a look at now why exactly that is by looking at that transformer's secret sauce, which is called attention. And in order to understand attention, you kind of need to understand how cheating worked back in the school days, right? So imagine this, you're in a surprise test that obviously you didn't study for. So you have this sheet of paper. On the paper, there's an objective. You don't have the information that you need to fulfill this objective, right? So what do? You have a little look to the left. You have a little look to the right. You identify relevant information for that question, and you put that onto your piece of paper, and that is basically how attention works. Let's have a look at this beautiful word sequence. Here, somewhere in the sequence, we might have the token he. What does he mean? Well, that is the question that the GPT now has to answer, the transformer. So what it does is it looks back in the sequence. And here we can see, if we look back in the sequence, we can see he refers to the shitposter as mad. So the next thing that the transformer does with its attention layer is to look back in the sequence to identify the words that are important, which is shit, poster, and mad, and obviously also he. And it takes that data, collects that, and puts it into the output. And instead of he, now we know shitposter mad he, and that is way more information than we had before, and that allows a transformer like GPT to understand text. And because it always just looks back in the sequence, what we can do now is we can give it a text and say, okay, give me the next probable token. And that is what we call autoregressive next word prediction. So for example, we can just give it the word computer, feed it into GPT. GPT is going to give us science because those two words are often found in a combination. And then now that we have the next token, we can take that, put that back into the input, run it through again. We get the next token and the next token and the next token until we hit what is called an end of text token. That's basically GPT telling us it's all done. And now that we've understood this, now we have to kind of train our model for shitposting,
yes,
right?
For this we have to gather data.
Yeah.
Do we get this data from?
Yeah, actually, the good thing is there is a couple of different open source shitposting data sets out there. Who knows one? Yeah, there's actually quite a few. They're called social media. And who has a guess which one we should focus on?
Twitter, okay.
Twitter X, what else?
Reddit. Perfect.
You guys know the internet, yeah. So we chose these two, we scraped from them, and interestingly, a couple months later, after we trained our first version of the shitposting AI, they closed off the APIs, and now you can't do this anymore. I wonder why. And with that, we trained our shitposting AI, and now we have this beautiful thing that we can use to just start a random conversation, and we'll carry on with the conversation for basically ever. What do we want to talk about today?
I would say the training data is from 2021 or something, so maybe COVID is a thing.
Yeah, all right.
Yeah, this could be interesting.
Let's try this very controversial take and see what it does with it. And here you can see it comes up with a reply to this. Funnily, it also makes up like a fake Twitter link. That leads to nowhere. And then the discussion is just going to go on about vaccines and, well, some takes in both directions, good and bad, mostly bad because we're on the internet, also some bad manners. And we can just have this run for the entire rest of the day and be sure that at some point somebody will come up with a point that we agree with. So we don't have to argue online anymore.
So, and now we can answer all those comments from trolls, yeah?
Yeah, exactly.
Automatically. Amazing.
Turns out this is not a good idea if you want to put this thing online, so we never did. All right, let's move on. Let's move on, because, yeah. So why is this relevant, Martin?
Whenever you argue with people on the internet, think about it, these could be bots. Yeah, we already mentioned that false news on Twitter, there's a 70% likelihood that there are retweeted, more likely to be retweeted than true stories. Yeah? And what is the reason for that? This number again comes from the MIT study we already mentioned. And they think humans' preference for novelty drives the speed of false news. It's not the bots. Yeah? Okay, so now we had the real-time deepfakes. We have the social media AI. What is missing? There is something missing, right? What can you fake? Audio. This brings us to audio deepfakes, that's right. And now we want to make a test with you. We have this sentence here, positive thinking can be contagious. So let's listen to it.
Positive thinking can be contagious.
Who is it? Arnold Schwarzenegger, perfectly right.
Positive thinking can be contagious.
So the question to you now is, did we just extract that from some of his videos, or is this faked? So hands up, who says this is faked? Okay, half of the audience somehow. And yes, you're right, it is faked. But now let's have a look to another example. What about this one?
The more you temper a sword, the stronger it becomes.
I will repeat.
The more you temper a sword, the stronger it becomes.
What do you think?
So, raise your hands if you think this is a fake. Okay. Audience is quite unsure about that. And we can tell you...
the more you temper a sword, the stronger it becomes.
Yeah, it might still be a deepfake, right?
Yeah, it could be a deepfake still, yeah? Thomas, do we want to, or Jonas, do we want to throw an eye on the architecture of something like that?
Yeah, let's jump into like how we could possibly build such a text-to-speech system with neural networks. We have an example here. It's a bit of dated neural network. It's called Tacotron 2. That's what you have in like your Google Home Assistant, for example. And as you can see here, it turns text into audio in two distinct steps. The first step is to go from text to what is called a MEL spectrogram. That is basically a visual representation of frequencies in time. And for that, we have a so-called spectrogram prediction network. The details don't really matter here. We have an LSTM decoder and encoder. And then we take that MEL spectrogram and turn that into a waveform. And we do so with another neural network, which is called the vocoder. And this way, we can, in a two-step process, turn text into audio, which is way easier than doing it all end-to-end.
Yeah. So now we discussed a lot of fake possibilities, and you know, probably you are somehow feared about that. And so we thought to have some positive vibes. Why not talking about possible ways on fake detection? So for this, we made some tests. Maybe we can use software on that.
Yeah.
Detecting fakes with software.
I mean,
And we
imagine
did so.
Yeah, imagine you see this kind of a video on YouTube, right? This is obviously the real Thomas ENDRES talking right now, and we're just not really sure. It comes from a fishy source, and we kind of want to find out, is this a real video? Is it a deep fake? It's kind of hard to tell, so
It's really hard to tell, yeah.
Let's use some deepfake detectors, right?
I took a frame out of this video, and
I normally have such a split head.
Yeah, 2 pairs of ears.
So we just did a research. We found a lot of software. We show you some of the best software products out of the way, and this is number 1. And Thomas, the two-headed Thomas, has a possibility to be AI generated by 0%.
Yeah. So a deepfake detector says it's real.
Yeah.
Yeah, it must be real.
But it was not the only one we tried out. Here's another one. It was much better, 0.1% suspicious.
Yeah, so here you can see like a big flaw of deepfake detectors. Those that are out there have been trained on commonly available deepfakes. We built our own thing, so it doesn't know them. And so they're always going to fail to our deepfakes.
Yeah.
Yep.
Liebe Mitbürgerinnen und Mitbürger, ich wende mich heute an Sie, weil unser Land einer schweren Bedrohung ausgesetzt ist. Einer Bedrohung, von der wir...
Fake or not fake? What do you think? Raise your hands if you think it's fake. Okay. You know the viral story, I'm quite sure. So, yeah, what did the software say? So it is fake, it is faked, and this was the best result. We gained 62% suspicious. And now think about what's happening if you have a software detecting if something is a fake or not a fake, and it's not 100% correct. Just think about you have a real video and software tells you it's fake. Isn't this crazy?
Everything that you gain is just kind of like a false sense of security, right?
Yes.
So that's it's making things even worse, effectively.
And we tried that out for audio deepfakes, for text fakes as well. So and the best we got for both audio and text was basically if it's not a well-made deepfake, then you will probably detect it. So there were quite some examples that we put in that were detected correctly. But if it was made in a good way, with good samples and good software, then you could not detect it anymore. Then it was more like a coin flip or something like that. So, but nevertheless, you got the Arnold Schwarzenegger right, and you can hear that by yourself, so you don't need software to do that for you and give you a false sense of security.
The question is now, though, now that we have AI and we cannot distinguish between real and fake, are we all doomed? Is AI the big problem here, Martin?
It depends. So fake news are existing for centuries, you know. Yeah. And let's have a look. So you don't always need high tech to fool people. This is Nancy Pelosi, and there was a video which went viral, and we want to have a look on that video right now.
We want to give this president the opportunity to do something historic for our country.
We wanted to give this president. Yeah, it really sounds a little bit drunk, to be honest. But what happened here?
We want to give this president the opportunity to do something historic for our country.
So this was the original video. Guess what they did? They just slowed down the video. If you compare them side by side, you can see the verified video and the altered video. And the altered video is somehow slower. So you might say, wait. If I slow down a video, what happens with the voice? It will get, how to say?
Pitched down.
It's pitched down. So let's have a...
Want to give this president the opportunity to do something historic for our country.
Yeah, the only thing you have to do here is you take the audio, you do a pitch correction, and then it sounds
We
like
want to
this.
give this president the opportunity to do something historic.
So you see, you don't need high tech. You can also do something like that, which is, by the way, called a shallow fake.
Yeah.
Yep, and you don't even need shallow fakes. You can just put information out of context. You can frame it in a specific way, and with that, people will also just believe you. So we have one example for out of context information. So this is actually not the Hyde Park, but it was framed to be the Hyde Park, and it was framed that the Extinction Rebellion group just left a lot of trash in the Hyde Park, which was actually not true.
Yeah.
So.
Okay, and this now brings us to the conclusion.
Yeah, like summing up, apparently AI isn't the issue. We just have a big fake problem, and the world is doomed nonetheless, is it? No. Okay, let's have a look
if you
at
want to
something
say so.
that we can do.
Yeah, so what can we do?
What can we do, yeah?
So actually, we did a research, and the International Association of Librarians, they had some ideas, and we can have a look on that. Thomas?
Yep, the first thing you should always check is, check the source. Because you can just click away from the story and try to investigate a little bit. Was there a mission behind what you just read or saw or something like that? You should also check the author, if it's a reliable author, if you normally also does correct stories, or if it's just someone who tries to fool everybody. And always have a look at the supporting sources.
Yeah. Another thing is, read beyond. So, you know, we live in times of clickbaiting. It's all about the title sometimes. And reading the title is often not enough. They want you to click on it. Read the story, read the whole story, and check the date. Sometimes reposting old stories doesn't mean that they are relevant to the current situation, for example. Yeah? And is it a joke? It's also possible. If it sounds too outlandish, then it's probably satire, maybe.
And what you can also check is your own biases, because if you think that this story just supports your point of view, then you should actually check twice, because it might be just reassuring your own opinion in this case. Mm-hmm. So you should really ask the expert in this case, maybe.
Yeah. At least you can ask the experts in lab coats.
Yeah.
Yeah. But we see there is another problem which was not mentioned by the International Association of Librarians, and now this brings us to this story. Attention span in today's social media like TikTok and Instagram is just a few seconds. Just use public transport and look at the people when they are doom scrolling. So there was this picture. Think about seeing this picture in your mobile phone. A father with 5 kids in the Gaza war zone. This story went also viral, and but there was again something wrong, because this picture is faked. So with a magnifying glass, you could see that there are missing toes, missing fingers and stuff like that, or that the bones have an unusual position and something like that.
There's more arms than children.
As well, and but you have to think about, you have your small display, you have just 5 seconds while scrolling, and then you just give this picture a like, and so the story spreads somehow. Yeah. And this is also a problem, that we don't take time nowadays. But the good thing is that we at least have the opportunity to do that. Yeah.
So the solution is a human one. We have to take time to think, and there's no technical solution that can take that burden off us. And this kind of brings us to the dual-use problem of AI. You know, AI is a very powerful hammer, let's say, and you can use a hammer to build a house, and you can just knock somebody's head in. And as long as there's hammers, people are going to use them to knock people's heads in. But there's also some useful stuff that you can actually do with AI.
We want to show that.
We want to show you, because we showed you a lot of funny and useless stuff today. We want to close off with something that is actually quite useful, and that is one business case that we actually built for a customer a couple of years back. And so you remember the segmentation from the deepfakes? You can not only do that for a face, you can also, for example, do that for entire persons. And that's what you're seeing here. So why would you use this? Think of the GDPR laws that we have here. Think of personal data. Well, this doesn't work too well anymore.
Yeah, if the faces are too small, then it's of course a bit.
Yeah, that's why we don't do this. No, but so what we built here in a prototype that works way better than what we just showed you is we built a GDPR compliant security camera. So we can film in public places without leaking personal information. We can still see that there's a person in the image. We actually don't pixelate it like this. We actually just make them, we completely black them out. We can still see, is there a person there? Is the person lying on the floor, maybe injured? Is the person unconscious? But there's no way of like snooping on people. There's no way of stealing data because all of this runs on the camera itself.
Yeah.
Nice. So there's some good stuff.
Guess
to
what?
AI.
We did it. On the second. On the second.
Yep,
Time's up. So this was our keynote, the AI elections, how technology could shape public sentiment. And we hope you had a wonderful Devox experience, and thank you.
Thank you very much.
You want my mic? No, it doesn't work. Or maybe you'll just...
The Martin microphone. Perfect.
Hello. Right. So you all want to know how it went with. Oh, there we go. Right. You'd like to know how it went, right? So, who got to play on the arcade machines? How many of you? Quite a few. It was really busy, and the scores have been verified, checked, triple counted, and I can tell you, with an accumulated high score of 41,770 points, someone didn't go to see many talks. Wade Langranger, are you out there? There he is.